Hello. Okay, so can you hear me?
Yeah, I hear you.
Okay, okay. So how are you?
Oh, thank you. Fine. Try to do something, and it's everything okay. How are you?
Okay, so I am fine, thank you. Okay. So basically today I will try to teach you about the land use land cover classification map using machine learning model. How you can easily implement the machine learning model and then make the land use land cover classification map in Google Earth Engine platform. Okay. So let's go on today's class. So just I simply share my screen.
Okay.
So can you see my screen?
Not yet. Yes. Yes. Now yes.
Okay. 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 So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis for beginners to advanced level. And we already covered our total fifth number of class. Today is our sixth number of class. Okay, so basically today I will try to discuss about the topic in Google Earth Engine platform, how you can easily make the land use land cover classification map in Google Earth Engine platform using the different types of machine learning. It can be random forest, it can be classification, regression trees, minimum distance, support vector machine. How you can easily apply this type of machine learning model and make the land use land cover classification map. Okay. So basically, I will. This is our today's course content: how to make the land use and land cover map using machine learning, how to make the land use land cover classification chart, how to calculate the land use land cover classification area, how to add the legend. Okay, how you can easily calculate the overall accuracy of this map. Okay, all of the details will try to complete to this class. So let's go.
Okay. Great.
So mainly when you want to make the land use land cover classification map in Google Earth Engine platform, we need to follow some steps. First of all, you need to selecting your region of interest. So you can simply select your region of interest. Suppose you want to make the land use land cover map for any region. It can be Dhaka city or it can be any region. So first of all, you need to select your region. You can easily import your shapefile in your Google Earth Engine platform. Suppose I want to make the land use land cover classification map for Dhaka city. So I simply import the boundary shapefile of Dhaka city in Google Earth Engine platform. So I simply import my boundary shapefile. This is my first step. Second, I need to choose and filtering the image collection. You can choose the Landsat or Sentinel, any image you can use. Same, all of the images you follow the same process. Okay, so you can choose Landsat or Sentinel image. Anyone you can choose, and then you can filter this image collection. So you can filter the image collection according to your region, according to the image metadata, according to the image specific date. You can filter. Okay, when we already covered the part how you can easily filter the Landsat, how you can easily filter the Sentinel-2 satellite imagery. We already covered this part. Okay, so you need to choose and filtering the image collection. This is our second step. Third step is that you need to collect the training point. Suppose you want to classify some feature on the surface, water body, vegetation, build-up area, barren land. So you need to collect the some training point according to your classes. You can get the training point for water body. You can take the training point for the vegetation. You can get the training point for the barren land or build-up area. You can collect the some training point from this satellite image. Okay, so which satellite image you want to display, you can just simply take the training point from the satellite image. If you want, you can also go to the field and you can also take the training point. It's also another way. You can easily take this from the ground truth data. Okay. In this time, I use here the satellite image, and from the satellite image, I want to collect some training point for the different features. And you need to merge all of the training point together. You simply merge all of the training point together. Okay. After this, you need to make a training data set by sampling regions. In this time, you need to extract the pixel value all of prediction band. So you need to simply add some prediction band. From this band, you need to extract some pixel value. all of the training point, you can extract the pixel value or a spectral signature you created. Okay, and then you need to create the classifier. It can be different types of classifier in machine learning method. You can use at the random forest, you can use at the classification region trees, you can use at the minimum distance and classify the image, and finally create the classified image. And then you can display the result and print the confusion matrix for your accuracy assessment of this map, as well as also calculated the area for each classes. Okay, so basically I will follow all of the step by step and try to make the land use land cover classification map. I hope you can easily got all of the step. So let's go a practical example. So here again the simple project we already done in Google Earth Engine platform for the land use land cover classification map for any district, sub-district in Bangladesh, and can make this in here. So let's go. So I just simply open my code editor and try to show you the practically all of the step by step. So here I already open my code editor. So in this time, which area I want to need land use land cover classification map, I simply import this area boundary shape file. So just I simply click on the asset tab. Suppose I want to work in this time for the Dhaka city region. So just I simply import the Dhaka city boundary shape file. You can see I simply import it in here. It's showing the default table variable name. I can easily change the name. Suppose I put this name, this is that ROI. You can use any name in here. I want to show the shape file in a layer. So just I simply use the map.add layer function and then simply call the object ROI. Okay, and this I simply use the map.center object for center focus of this boundary shape file. I put here the zoom level 10 and click the run. So now you can see I simply import my shape file. This is my boundary shape file. For this boundary shape file, I need to create land use land cover classification map. Okay, this is my first step. I simply select my region. Second step is that I need to choose and filter image collection. If you want, you can use at the Lancet, or if you want, you can also use at the Sentinel. Okay, both of images are the same process. You need to apply. So in this time, I simply go to the browse data catalog and find out my image collection. Lancet, Sentinel, both of these will be same. So in this time, I want to use suppose Lancet. Just I simply click on the Lancet. Then I can get all of the Lancet image collection in here. Okay, so here I can get all of the Lancet image collection. Which image you want to need, you can see this image collection. You can get the year of 2020 to present time. Also you can see 2013 to present time. Also you can see this time period. Also you can see which time period you want to need to make the land use land cover classification map. You simply click on it. Suppose in this time I want to use here the Lancet 8 image area. Here you can see top of atmospheric and raw image and surface reflectance. So mainly when you want to make the land use land cover classification map, we need to use here the surface reflectance. This satellite image we need to use for making the land use land cover classification map. So just I simply click on the surface reflectance. So now I can get all of the, you can see all of the band name. A surface reflectance band 1, surface band 2. I get all of the band, as well as I also get the description. And this image the already atmospheric corrected or atmospherically corrected. You can see it already atmospherically corrected. Surface reflectance, all of the things already done. So in this time I use this image collection. So first of all, I need to import the image collection in my code editor. So just I simply copy this Earth Engine snippet from here. I simply copy this Earth Engine snippet from here and then paste in my code editor. So I simply import my image collection in here. I simply put this name, suppose L8. You can use any name, no problem. In this time, I need to use the var keyword, var, and put the ln. In this time, I just need to filter this image collection according to my region, according to my image specific time period, according to the image metadata. I simply filter. I simply take a variable and put the variable suppose image. Okay. I simply call the L8. because I stored all my full image collection in the variable name is the L8. I simply put the L8 and use at the filter bounds function. Okay, filter bounds. I simply call my shapefile ROI. And then I just simply put here this, suppose I simply put here this filter date function. Suppose I simply work for the land use land cover classification map for year of 2021. I simply 2021 1st January from 2021 December 31. I simply put this, and then I simply use the filter metadata, and I put here this image properties cloud cover less than 1. Okay, then I check how many images I want to get in here. You can see I simply use the print function and call the image and use the size function. Here I can get for my region of interest Dhaka city total how many images I on four images I want to get. Okay, so in this time I want to create the median composite and then try to display the all of the 4 images in here. So just I simply use the median composite median, and after this simply use the clip function, clip with my boundary shapefile ROI. Okay, in this time I display the result, this image in here. I simply add a layer. I simply use the map dot add layer function and then simply call the image and click the run. So now it also added the image in here, you can see. So now you can see I can get the image look like this. I need to add here the visualization. I simply click on here and then add here the suppose B4, red band, green band, and blue band. Also increasing the 98% for better looking, and apply. So now I can get very good quality image. You can see I can get in here. So in this time, I just use this image for making the land use land cover classification map in here. Okay. So in this time, I just simply import this visualization in here. So a new line code will be added in here. I simply copy the visualization variable name and paste after the object name in here. Okay, so now it will be set the visualization with my code. In this time, this is my second step is done. Okay, choosing and filtering. I choose my image land set and then I simply filter this image. If you want, you can choose the Sentinel-2 and you can also filter the Sentinel-2 satellite image. And then you can get the composite, this like of satellite image you created. In this time, I move to the third step. Third step is that I need to collect some training point, such as water body, vegetation, barren land, build-up area. Actually, which class you want to identify. Okay. Okay, so for this collecting the training point, I just simply click on here. You can see the add a marker. Simply click on here. Then I simply click on this geometry. Okay. Suppose I simply take the training point for water. I simply click on here the water. Okay. And then just simply press here the feature collection and property. Property name I simply put here the property, suppose class. You can use any name as a property. And set the value for water. I simply put at the 0. Okay. Then okay. In this time, you can see it will be select. I simply select this water and take the some water body from here. Okay. So I simply take the training point for the water body. Suppose also some training point for water body in here.
And I can have many classes, yeah, a lot of classes. It depends on my territory.
Yeah. You can add this class a training point according to your classes.
Okay.
Okay, so I simply take the training point for the water body, then create the new layer again, and then click on here. Suppose in this time I want to take the training point for build up area. Build up. And feature collection property, I simply put the property suppose class and set the value for 1. Okay, then okay. So in this time I take the training point for the build up area. I select the build up area and then simply take the training point. This is the build up area. There is a lot of build up area we can find out. Then I simply click on here again. In this time I take the training point suppose for vegetation. So just I simply use at the vegetation. Okay, then simply feature collection again, and property name is the same class. Okay, then use at the for 2 vegetation for 2 I simply put, and then I simply find out the vegetation from the vegetation, and we are using here the different types of band combination for identify the different types of feature. In this time suppose I simply use here the band combination look like this, suppose B5 then 4 4 and use a band B2 98% and use here the apply. So now you can see here I can get the red pixel value. This high red pixel will identify the dense vegetation in this time, and the black is identify the water body. Okay, and this white is identify this type of build up area. Okay, so in this time yeah, so the mainly this band combination we can use for identify the vegetation. Suppose you can also try to follow this link. It has also give the some Landsat band combination also. Landsat band combination we search in here. So we can use here the different types of band combination for identify the different types of feature on the surface. You can easily find out. Okay, so you can see this link. Okay, so here you can see a natural color 432. This is the red, green, and blue band. When you can use this, we can get the image look like this. And here you can see it replicate the close to what our human eyes can see. And healthy vegetation is green, unhealthy flora is brown, urban feature appear white and gray, and water is the dark blue or black when I use this band combination. Also, you can see the 543. When I use this band combination, mainly it useful for analyzing the vegetation, and it the red has the better vegetation or healthy vegetation. Dark areas are water, urban areas are white. Look like this color we can find out. Also you can see short wave infrared. When I use this band combination, it while darker shade of green indicate the denser vegetation, sparse vegetation is the lighter shade, and urban feature are blue, and soil have the various shades of the brown color we can find out. Also you can see agriculture 652. When you can use this, mainly we can use this band combination for identify agriculture, such as you can see healthy vegetation is the appears the dark green, and the barren land we can get the magenta. This type of color we can get. Okay. Also you can see geology. So you can also read this and also apply the different types of indices and identify the different types of feature from your satellite images. Suppose I simply use L3 and then apply this. So now 543, it's identify the false color composite. And mainly when I use this band combination, here I can get the red pixel value. It's identify the better vegetation. So I simply select the vegetation and then simply take the training point for the vegetation from the red. Okay. Also you can see what this is the also we can find out the some water body also in here. You can see dark, okay, or black color we can find out. So I simply take the training point for the vegetation.
Okay.
So just I simply take the some training point for the vegetation. Okay. So in this time I simply take the training point for the barren land. For the barren land, I can use this band combination 652. 652 I simply use here. For the barren land, 6, 5, 2, then apply. So now I can easily find out the some barren land or fallow land from the satellite images, and I can easily get. You can see this is the barren land. I can easily find out. Okay, so just I simply click on the new layer button, and then simply click on here, and then I take the suppose barren land. Okay, then feature collection and property. I simply put the properties such as class and set the value for the barren land 3, and okay. So now I simply select the barren land and take the some training point for the barren land. You can see. What's the barren land?
How do you think if we have a lot of points for each class, our accuracy will be higher?
When you want to get the more training points, suppose I want to take the training point for the water body, more training point, you can get the better accuracy also. Okay, so you can get the training point when you suppose you want to need the very good accuracy, you can get the training point as much as possible. You can get. Okay, then run your model, and when you can see your model accuracy assessment is not so good, then you can also need to increase the training point. Then it also okay. Okay, just I simply training point for the barren land. Okay, so now I simply take the training point in this time. In this time, you can see I just simply take my training point, such as water, build up, vegetation, and barren land. Suppose you want to need to classify the other classes also, then you can also add the training point for other classes also in here. In this time, I just simply classified the water body, build up, vegetation, and barren land. And you can see I just simply complete my process for this process. I simply done collecting the training point. Okay, so in this time I need to merge all of the training point. Okay, so for the merge, I simply use here the merge function and try to merge all of the training point together. So I simply take a variable. Suppose this variable name is a sample. Okay, and then call the water. Then use here the merge function and also merge with build up, and it also merge with vegetation, and it also merge with barren land. I simply merge all of the training point and store sample, this variable. In this time I simply print this. So I simply print this sample and click to the run. So now I can get all of the training point. Okay, you can see how many training point I can use in here. We can easily get. It will be calculating. You can see here I total 123 element in this time. Okay, so here you can see I simply click on here. Here I can get all of the training point. Okay, so in this time I just simply click on here. Suppose this training point, we can get this training point lat long. Also you can get the properties class 1. So for this training point I use for get the training for the class 1. Class 1 is the build up area. So for this 71 number of training point I can use for train my build up region. Okay, suppose another training point you can check. Suppose you can see lat long about this training point, and what is this? You can see class 2. So this number of training point I can use for identify the class 2. What is the class 2? Class 2 is that vegetation. Okay, because you can see when I use here this, I can set the value for the 2. So all of the value 2 training point identify the vegetation. All of the value 0 training point identify the water body. All of the value 1 training point identify the build up area. Okay, so this time we can easily get all of the training point in here. Okay, in this time I just need to extract the pixel value. Okay, so here I can see here I add all of the band value in this time in here. In this time I just need to extract band value from all of the training point. I need to extract the band value and create the data set. Okay, so for this I just simply take a variable first of all, I simply put the variable name such as band, suppose bands, okay, and make a list all of the band, which band I want to use for extracting the band value. So in this time I simply put here the band name, suppose I simply check, you can see. So you can see all of the band in here, SRB1, SRB2. So I simply select all of the band and then extract all of the band pixel value. So SRB1, surface reflectance band 2. Then I'll sweep user the SR, surface reflectance band 3. User surface reflectance band 4. And also put here the surface reflectance band 5. Also put here the surface reflectance band 6. Also surface reflectance band 7. Okay, so in this time I can simply put band 7. I take all of the band B1, B2, all of the band I simply put. In this time I just need to extract the band value. I simply extract the band value and then make the training data set. So I need to all of the band value for each point. Okay, for the each point I need to all of the band value in this time. Okay, so you can see it will be outside our satellite image. I simply remove, I simply select this and then simply delete. It's not needed because it's outside of the images. Okay, in this time I simply select my band SRB1, all of the band I have to select. In this time I just need to extract all of the band pixel value for each point. Here I can get total 183 training point. So 183 training point I need to extract all of the band value for each point. Okay, so let's go. We try to extract all of the band value from here. So first of all I simply take a variable. Suppose I simply put the variable name is suppose train image. You can use any variable name, and then I just simply call this my image. Okay, I simply call this image because I want to extract the band value from this image. So I simply call this image, simply copy the variable name and paste here. Okay, then which band you want to extract? I want to extract all of the band. Okay, so I simply use the select function, select, and then call all of the band. I simply copy the variable name and paste here. Okay, and then I use a function. Its function name is that sample regions, and put all of the argument one by one. Then it will be automatically extracting all of the band pixel value. So for this I simply make a dictionary in here, curly bracket start, and also curly bracket int. Okay, in this time I just simply click on the collection. So first of all, collection is that all of the training point. So all of the training point is stored in this variable sample. I simply copy the sample and paste here. Then properties. So these properties I want to use the properties such as property name. I simply put here the property name. You can see when I want to take the training point, I add here the property name is the class. Okay, so this is my properties name, class, and I simply use the square bracket and put here this class in here. Then scale is the resolution. In this time 30-meter resolution. Okay, I simply remove all of the for this time. I simply remove, it's not needed for this time. In this time I just simply print this training data set. I simply print this train image, simply copy and paste here this variable and click on run. So now you can see in this time all of the band value will be extracted. Okay, I can get all of the band value for each point. Each point I can get total 7 band value. Okay, you can see when I simply click here and go to the feature, suppose this training point 22, I simply click on here. You can see I can get all of the band value for this training point. I can get all of the band value. I can get, and it is the class 0. So all of the band value I can easily extract from here. And now I want to use this band value as a training data set and then try to make this land cover classification map. Okay, so this is my data set. This data set I want to create it in this time in here. Okay, so I simply extract all of the band value, all of the total 7 band in here. You can see total 7 band, B1, B2, B3, B5, B6. We can get total 7 band. So in this time, I want to use this all of the band value and create the data set. My data set is stored in here. This data set, I apply different types of machine learning algorithm and train my model and create the land use land cover classification map. Okay, so let's go. So for this, suppose in this time, you can get the lot of classifier in here. You can get the lot of classifier in documentation tab. You can see the lot of classifier available here. So you can see I simply use this classifier. So mainly this is the classification and regression trees. Classification and regression trees. I use this classifier and then try to make this land use land cover classification map. Okay, so let's go how I can use this. So just I simply copy this function from here. I simply copy from here, just simply copy, and then paste here. Okay, and give a variable name. Suppose this variable name is that classifier. Okay, you can use any variable name, no problem. In this time, I create the classifier. Okay, so I simply remove it. This classifier I want to train with my data set. I simply use the train function. Okay, and then I simply put all of the argument one by one and train my data set. Okay, so for this I simply use here this make a dictionary in here. I use that the curly bracket start and curly bracket int. And first of all, feature. This feature is that which data set. My all of the data set is stored in here. I simply copy and paste here. Okay, then class property. So class property is that your property name. So property name is that class. Okay, because you can see I use here the property name is the class. I simply use here the class. Input properties. Input properties is the all of the band. All of the band is stored in this variable bands. I simply copy and paste here. Okay, in this time it's not needed. I simply remove it. It's not needed for this time. I simply remove it. Okay, and then I just simply just print this. Then I can get the classifier. Suppose I simply use here the print and then simply call the classifier this variable and use here a function. It's the get info function and click to the run. So if I did not get any wrong, then it will be executed. You can see. Okay, so you can see we can get the classifier train. And class property is the class classifier dot smile cart. In this time we are using here this classifier trees. Input properties total 7 band we are using for make this train my model. Okay, so in this time we can use here this classifier and then classified our image. So you can see this classifier is ready. In this time this classifier I need to add with my image. Okay, so this classifier when I want to add with my image, then it will be classified. So for this, I just simply take a variable. Suppose I can simply put the variable name is that classified. I can use, then I simply call my image. Which image I want to classify? I want to classify this image, and this image is stored in the variable image. I simply copy and paste here. Okay, and this image has also some band. I simply use select my band and then call the band's variable name and then paste here. Okay, and finally I use here this classify function. Classify with my classifier. So I simply call this variable classifier and then paste here. In this time what happened, you can see this is my classifier and this classifier is stored in a variable classifier. I simply call my image which I want to classify and also which image, which band I use here. I simply select this band and use the classify function and call this classifier variable name. So now this classifier is added with my image and make the classified image. So let's go. We can display the image. So I simply use the map dot add layer and call this classified and click to the run. You can see a new layer will be added here, but we did not add anything because I did not add the visualization yet. So without we can totally get the black color map. You can see one layer will be added here. So in this time, I simply add here the visualization. Then we can easily identify the water body, build-up area, vegetation. Okay. So in this time, I add here. So I simply make a dictionary in here. add the visualization. You can say I can get totally this type of color. I simply make a suppose mean. It will be start from the 0 and max up to 3, because you can see when I want to use at the water, I use at the okay. A minute for the water. I need to use at the 0. Sorry, it's a water is the 0. So water is the 0. Then also you can see built up area is the 1. Also you can see the vegetation is the 2, and barren land is the 3. Okay, barren land is the 3. So I simply add this, and then so you can see this is the mean and max. Mean it will be start from the 0 and max up to the 3. I just simply use the color plated in here. So color plated is simply used. Suppose 0, identify water. I want to show this blue color. Then 1 is the build up. I want to show a build up is a red color. And then vegetation, I want to show the green color. And then I show the barren land is a yellow color. Okay. Then I want to click to the run. So now this color also added with my image. Okay, it's working.
Oh, yes. Great.
So now you can see we can get this classified map in here. Okay, so we can classify the water body, and then red is that our build up area. And here I can get the lot of build up area as a red color. And this identify build up area. Also you can see barren land, vegetation, water body. Okay, so in this time, what happened in here? So in this time you can see when I want to take the training point, suppose I simply take the training point for the water body from here. I take the training point water body from here. When this pixel value is similar with other region, suppose in this time I take the training point in here, but we can also get the water body in here in this region. You can also get the some water body, also get the some water body in here. Okay, so it automatically identify when it will be similar with this. It automatically identify this is the water body and represented it is a water body. Also you can see build up area. I just simply take the training point from here, but it also identifies the lot of build up area in here. Also you can see when I want to take the vegetation, I take the vegetation area from here, but it also identifies the lot of vegetation area in predicted lot of vegetation area also in here. Also you can see barren land. I take the training point some barren land in here, but we can also find out the lot of barren land in here. Okay, so we can create this classified map in here. So in this time we need to check what's the accuracy of this map. Okay, accuracy is the good or bad. We also need to calculate the producer accuracy, consumer accuracy. Then we can get the sum wrong. We can get the low accuracy. Then we need to also apply that, change the training point and also increasing the training point. Okay, and then finally we can calculate the area. So let's go for calculating the accuracy. So mainly we can calculate the accuracy different way. If you want, you can go to the ground truth data set and use the ground truth data set as a training point. It also okay. Or if you want, you can also use the satellite image. Suppose you can see when I want to use this satellite image, then I can very closely I can identify different types of feature. You can see I can very closely I can easily identify the different types of feature on the surface. You can see when I want to simply closing use this satellite image, I can easily identify this is the water body. Okay, so in this time you can get the ground truth data, or if you want you can also use the another way. You can simply go to the satellite image and take the some training point as a ground truth data for your check the validation data. So in this time I will also try to show you this part how you can easily do this. So just I simply open my another project work, then it also better. I already done this part. So just I simply copy this code link from here, simply copy and then try to open.